One variable data, distributions, and measures of center and spread. What does that mean? That's about median, mean, and range. You could also do mode and other things. So I have done a video doing easy, medium, and hard, but if you just want to focus on the hard questions, I have them all right here for you. Try them out, let me know how you do, and enjoy. Okay, now we're on to the hard ones. Let's see just how hard these are. The box plots summarize the distance in meters a group of people ran in a certain amount of time. Group 1 is the group above, and group 2 is the group below. Based on the box plots, which of the following statements must be true? The mean distance of the group is greater than the mean distance of group 2. We can't really find the mean just from box plots, so it's probably not going to be that. The mean distance of group 1 is less than the mean distance. Again, probably not that. The median distance of group 1 is greater than the median distance of group 2. And the median distance of group 1 is less than the median distance. So they're using the same axis here, even if we can't totally read it. And this one is greater, right? The median is greater than this. So median of group 2 is greater than median of group 1. And that would give us D. The median distance of group 1 is less than the median distance of group 2. Okay, so we have questions on this one. Let me know. It's just about reading it carefully and understanding. Honestly, I think the hardest part is reading the answer choices carefully and not getting confused about which one's greater and which one's less in each option. So now we have HB. Dataset A consists of 10 positive integers less than 100. The list shown gives 9 of these integers from dataset A. The mean of these 9 integers is 87. If the mean of dataset A is an integer greater than 87, what is the value of the largest integer in dataset A? This, for my money, is probably the hardest question in this category. So what's happening is they're telling us dataset A, is what we're seeing, has 10 numbers. And we're seeing 9 of those numbers. And there's another number, let's call it X. Now, within X, something's going to happen. The mean of these is 87. We're going to trust that. If the mean of dataset A is an integer greater than 87, what is the value of the largest data in the dataset? So the mean is greater. So this has to be greater than 87 to push the mean up from the 87 it's already at. So we could find the value it is at, and it has to be less than 100, and it's an integer. So the current mean is 87. The new mean, we don't know what it is, but it could be 88, could be 89, could be anything. Could be any value above, but it wouldn't be above 100, right? Because X can't even be above 100. So let's say the new mean is 88. Okay, in this world where the new mean is 88, let's find the sum from the first 9 numbers by doing 87 times 9. Equals 783. 783 equals sum of 9. I know that because the mean is 87, so you just multiply that by the number of numbers to find the sum. Now, if the new mean is 88, we would just do 88 times 10 to find the new sum, and that's 880. And then we would subtract 783 from it, and we're going to get 97. So X could equal 97. If X is 97, that's bigger than any of these numbers, so the biggest number would be 97. Now, what happens though if we do 89? You're like, Sebastian, why can't it be 89? Well, I'll show you why. 89 times 10 gets us a beautiful 890. And when we subtract 783 from that, we get a lovely 107, but that's greater than the 100 they tell us about. So that's not going to work. X has to be 97, and that means 97 is the biggest value in these. So these conditions that feel kind of weird, they limit our answer to one option, and that gives us the answer we're looking for. So it's all about just reading carefully and not freaking out when it feels abstract, and just trying things out and then go from there. Now we have distribution category C for the new album by Bon Iver, Sable Fable. Different listeners gave it a different rating from 1 to 10. The table to the left shows the frequency distribution of scores of the 13 players in Group A and the 15 players in Group B. The median of the scores for Group B is how much less than the median of the scores for Group A. This is similar to the one we did earlier, except now we're dealing with frequencies. Also, this is a great album. Anyone who's giving it less than an 8, get out of here. Your ears have to get fixed. So we have a total of 15, so we're looking for the 8th person, and we have a total of 13, so we're looking for the 7th person. So the 8th person here, we go 1, 2, 4, 8. The 8th person gives it a 7. Unbelievable. And then here we have a 7th person. So 1, 2, 3, 4, 9. So the 7th person is somewhere here. It gives it an 8. Okay, that's a much more acceptable. So we would just do 8 minus 7, which is anyone? Right, 1, exactly. Okay. And check out this album. It is great. I would listen to From. That was one of my favorite songs on it, but honestly, the whole thing. The chart to the left displays the scores students in different classes give to Addison Rae's new album. Class 1 gives a mean score 0.2 points lower than Class 2. What is the value of X? So it's a mean score 0.2 points lower. I don't know about Addison Rae's music, so I won't judge the scores. So let's find the mean of Class 1. Okay, so what we'll do is we'll add these together. You can do it in Desmos, and I'll give you 42.6. And we're going to subtract that from these. Or we're going to take these and subtract it. Now 42.6, and now we're going to add this on. We're going to add 1.2 onto that. Okay, so we're going to do, because we have 6 times 0.2, and that gives us 1.2. And that'll be 43.8. Now we're going to subtract these from it to find the remainder, which would be the X value. So add those together and then take them away from 43.8, and you will get 7.1. X equals 7.1. All right. It's a little tricky, and you want to make sure that Class 1 is 0.2 points lower. If it had been Class 2 was 0.2 points greater, you would take away that value. So just be careful with the wording. Now let's go to E. A survey for favorite ice cream flavors across the nation has a median of 30%. The results from 8 cities are given in the table to the left. What is the difference between the median percent of the cities in the chart and the median percent of people across the nation? So across the nation, it's 30%. And now in the chart, let's see. So here we're comparing something in written form versus a table. So let's go lowest, I think is 23. Highest is 38. Second lowest seems to be 26.3. Second highest seems to be 31.2. Third lowest is 27. Third highest is 30.5. And then we're left with 28.3 and 29.9 as the two middles. So do 28.3 plus 29.9 and divided by 2. One thing I like to do sometimes is just find the difference of them. That could be easier. I can do that more easily in my head. 28.3 equals 1.6. I divide that by 2 and I get 0.8, and I just add that on to the 28.3 and I get 29.1. That's the middle. And that is, when we do 30 minus that, that's going to give us 0.9% as the difference. And that is A. And again, of course, you have your friendly Desmos to work with. Okay. So now we have F. Dataset A consists of the masses of 60 objects and has a mean of 30 kilograms. Dataset B consists of the masses of 90 objects and has a mean of 35 kilograms. What is the mean in kilograms of the two datasets combined? So if they were perfectly balanced, you could just take the means and find them if they were the same number of objects. But here you account for the different number of objects. So you do 60 times 30 plus 90 times 35. So you're going to get 1800 plus 3150. So you'll get 4950. And you're going to divide that by the total number of objects, which is 90 and 60, 150. And that will get you a nice clean 33. Okay, so the way you account for their different sizes is by multiplying each of them by the number they have of them and then dividing by the total number. And you can do that with mixtures, you can do that with this. It's something you do in chemistry. In chemistry, you can do it to find the average of isotopes or mixtures that you make. So it's something that's very helpful, actually. It's one of my favorite types of questions. Dataset A consists of 60 integers between 20 and 80. Dataset B consists of all integers in dataset A as well as the value of 90. Which of the following must be true? Mean of dataset A is less than the mean of dataset B. Range of dataset A is less than the range of dataset B. And median of dataset A is less than the median of dataset B. So dataset B is identical to dataset A except it has a 90 added on. So that will increase the range. So the range of dataset A is less than the range of dataset B is true. The mean will also go up. This is like when we did earlier. And then the median will not be changing. Or if it is changing, it's not going to be dropping. Although it won't be changing. So why am I even saying that? So it's going to be 1 and 2D. Just read carefully what's going on and think about how dataset B is identical to dataset A except you have a number that's bigger being added on. If it was a number in the middle being added on, then it's, I don't even want to say what it is because it's a bad word, but it's a thing, you know? All right. Then we have which frequency table to the left shows the dataset with the greatest mean. Are we going to find the mean? You bet we're not finding the mean. Because why do all that work? We're going to study the distribution and think about it like Einstein's. The mean here is going to be 2.5. So I guess I found it, but not really doing the math because it's perfectly distributed even. You see how they're all 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We want ones where the frequency is highest at the end. So the frequency here is lower than at the end, so it wouldn't be that. It's actually, this one's higher, so it's not going to be that. Frequency here is high at the ends, but they sort of balance each other out, so this would also be a 2.5. But the frequency here, you're pushing it, and you're going to get more numbers are weighted toward the bottom, so we're going to have more numbers there toward the, not toward the bottom of the chart, but higher values, so it'll be C, because there's more big numbers there. If you think of 4 as a big number in this world of 1, 2, 3, 4. We don't even get to our thumb yet. So that's all you have to do. I'm not even going to bother showing you this because you got to just trust me. You could work it out, but you're just wasting your time. All right, so we have this lovely question here. 2 different teams consisting of 10 members each swam in a race. Each competitor's time was recorded. The mean of the finishing times for each team was calculated and is shown below. Team A, 5.56 minutes. Lovely. Team B, 6.65 minutes. A beautiful number. Which of the following must be true? Every member of Team A completed the race in less time than any member in Team B. Okay. There's at least one member of the Team A who completed the race in less time than any member in Team B. Okay. The median completion time for Team B is more than the median completion time in Team A. Then we have 1 only, 2 only, 1 and 2, and 1, 2, 3. So, is 3 true? No, because we don't know anything about the median. It could be true, but it's not necessarily true. Then there is at least one team member of Team A who completed the race in less time than any member in Team B. Okay, so what this is saying is that at least someone in Team A beat someone in Team B. And that has to be true, because if no one in Team A beat anyone in Team B, how the heck would they have a faster finishing time? So 2 is true. And then 1, if every member of Team A completed the race in less time. That's not necessarily true. Just the average time, but not that everyone did it. So it's going to be B as in boy. All right, so now we'll go on to this. HJ, 2 data sets with 40 integers each are summarized in the histograms shown. For each of the histograms, the first interval represents integers greater than or equal to 0 and less than 10. And each interval after follows the same pattern. What is the smallest possible difference between the mean of dataset A and the mean of dataset B? So if you can see this, right, we have 4, 6, 8, 10, 12. There's 40 people, 40 here. And they're shifted on this one. It's to the left, 0 to 50, and here it's 10 to 60. So what is the smallest possible difference? So in this world, let's say everything is at the maximum, at the minimum here, and at the maximum on data set B. That's how we're going to get the smallest difference between them. So we have to find min and max. So the min on this would be, we have 4 10s, 6 20s, 8 30s, 10 40s, and 12 50s. And the min here, and now the max here would be 4 9s, 6 19s, 8 29s, 10 39s, and 12 49s. Now what I want you to notice is how everything in this is 1 less than everything here. So then its mean difference is going to be 1. You could multiply it out, then divide by 40 and find it, but I'm not going to do that because you don't need to do that. So what you do, right, is you find the difference here is 1, 1, 1, 1, 1. So everything's 1 less here, so the mean would be 1 less. We're going to have C. Okay. As you can see on this test, on this category, there's a lot of hard level questions. There's more variety in the hard, so there's usually more types that I do for that. That doesn't mean that there's going to be more hard on the test. There's just more types you need to learn that are hard than the easy. The frequency distribution to the left summarizes a set of data where B is a positive integer. How much greater is the mean of the set of data than the median? Okay, so this is a bit more abstract again. We have 5b instead of actually finding it, but we have 5b, 4b, b, 4b, 5b. You see how it's symmetrical? And these numbers are all symmetrically spaced. They're evenly spaced. So then, like that one we did where there were 7 numbers that were consecutive evens, here we have consecutive odds. And because these are balanced, we don't have to find it again. It's going to be 105 for both of them, and our answer is D. If they weren't balanced, then you don't have to worry about the B's because they cancel out. You would just do 101 times 5, 103 times 4, 105 times 1, 107 times 4, 109 times 5. Add them together and then divide by the sum of the 5, 4, 1, 5, which would be, 19, I think. So now we'll go to the next one. As you can see, these are conceptual. What makes them hard is they're conceptual. They're not hard to solve the regular way. They're hard to solve the fast way. And you want to solve them the fast way because on the test you'd have these, and then you'd have harder ones that actually would take a long time, and you need to save time for that. 2 box plots show the distribution of the number of movies seen by students over a weekend. What is the positive difference between the ranges of numbers of movies seen over the weekend? So here we're going from 10 to 3, so we have 7. Here we're going from 9 to 4, so we have 5. So then our difference will be 2. Honestly, I don't know why this one's considered hard because that feels pretty straightforward to me, but the SAT deems it so. Now we're talking. The frequency table to the left summarizes data on the mass of 47 objects. An object of 22 kilograms is added to the original data set, creating a new data set of 48 objects. Which statement best compares the mean and median of the new data set to the mean and median of the original data sets? So we're adding an object of 22 kilograms. Like the before, that's bigger than any of the masses we have. So let's see what happens here. The reason I have this as its own category is just because it's a different type of chart. It's a frequency chart, but the concept is similar to what we did before. The mean are both greater. I wouldn't say the median. The mean and median of the new set are both greater than the mean and median of the old set. No, because the median isn't changing, I believe, but the mean is. The way we can find the median, 47 objects. This is an order from least to greatest, so we'll go to 24th object. So it'll be 10, 13, 21. The 24 and 25th objects are here. When we add in the new one, we're basically finding the 24.5 objects, so it's still 15. It's staying the same. Then the mean of the new set is greater, yes, because we're adding a bigger number than we had, but the medians are equal. That is true, so it should be B. The median and medians are both equal, no. And the mean is less than the old, but the median is equal, no. it's going to be B as in boy. Okay, again, we've done a couple that are like this with a different type of chart or data, but if you're adding a number that's bigger, you're going to be moving the mean up. If you're adding a number that's smaller than all the rest, you're moving the mean up without having to calculate. Don't calculate. Save your brain for harder questions. The frequency table to the left summarizes data on the mass of 40 objects. Which of the following could be the median mass of the 40 objects? So we have 40 objects. We want the 20 and 21st objects to find the possible means, or median. So 5, 7, 11, 17, all the way to 28. So the 20 and 21st object are all here in this category. So the value has to be between 21 and 25, and that is C. Nice and clean again. I'm loving these hard questions. I want you to be able to get 100% on these types of questions. So if you have any doubts, leave them in the comments. The dot plot represents a data set of the number of pets 27 students have in a class. If a new student joins the class and has 2 pets, which of the following measures will be greater in the original data set than in the new data set? The median or the mean? So there's 27 students. Let's see where the median is right now. We have 5, 9, and then the 14th and 15th are here. So if we add a person in, the 14th and 15th would still be here, and we are keeping the median the same. So it's not going to be median, so 1 is not going to work. But the mean is going to drop because now we're going below, right? We have a 2 here. So the mean will drop, so the original data set has a bigger mean. So it'll be B as in boy. All right, so that's the video for today. I hope you enjoyed it, and I hope you nailed them all. If you had any you had questions on, put them in the comments and let me know if you thought this was actually the hardest questions you've seen on this category, or if you've seen harder. Bye.